Good morning, class. In our last session, we have started the chapter Chemical Kinetics, which is the fourth chapter of physical chemistry. And there we came to know about what is chemical kinetics, what are the different types of reaction based on the rate of reaction. Now, and after that, we have seen the factors affecting the rate of reaction. Today, we are going to see what does a rate of reaction means, what is average rate, and instantaneous rate of reaction. So, rate of reaction. Rate of reaction is defined as the change in concentration of reactants or products per unit time. So, whatever change in the concentration of reactant and products takes place during the time, that is known as rate of reaction. So, rate of reaction will be given by, say for example, if you have got a reactant and it is forming a product, then rate of reaction will be equal to decrease in concentration of reactant by time taken. Because once the reaction starts, what will happen? The reactant gets less, okay, whereas the product get increased. So rate of reaction is given by decrease in concentration of reactant by time taken, or it is also given by increase in concentration of product by time taken, because product get increases. Or say for example, if you have got a general equation that is A reactant giving you product B, then we can write a reactant rate of reaction as R equals to minus delta A, that is change in the concentration of reactant, by delta T during the time, or delta B by delta T. Now if you notice, then we have written minus over here. This minus means there is a decrease in the concentration of the reactant. Okay, so this is the rate of reaction. So this graph shows how the concentration of reactant and product changes with time. Say for example, on the x-axis we have plotted time, and along x-axis the concentration. Now the reactant at the beginning, it will be at very high concentration, will be very high, but as the reaction proceeds with the time, it gets decreased. Okay, the reactant concentration get decreased, whereas the products at the beginning, it's zero, but as the reaction proceeds, the product get increased. Okay, the product gets increased. So this graph shows how there is a change of concentration of reactant and product with the time. Next, average rate of reaction. What is the average rate of reaction? Average rate of reaction means when the rate of reaction is calculated or determined for a certain interval of time with the change in concentration of reactant or products is known as the average rate of reaction, and is represented as follows. So here we need to know the representation of the average rate. So R average is written as, suppose if you have taken the reactant, okay, A giving you product B, so we can write rate average equals to minus delta A by delta T. Okay, or that delta A means change in concentration of reactant will be final concentration minus initial, and delta T is final time minus initial. So this is how we calculate rate average equals to minus delta A by delta T. Whereas instantaneous rate of reaction is given by RIN's instantaneous equals to minus dA by dt. This is the differentiation, we can say. Okay, in mathematics we have got this function as we call it as a differentiation, where d2 tends to 0. Okay, now how to express the rate of reactions into instantaneous rate? Say for example, we have got a general equation A plus B giving you C plus D, and small letters A, B, C and D are the coefficient. That means we can say the number of that molecules. Okay, now from this equation, if you have to write the rate of reaction, then it will be given by minus A by small a, this is the coefficient, by delta A by delta T. Okay, or minus 1 by B by delta B by delta T. So we have represent minus over here. That means this is a reactant and they are getting decreased. Okay, next rate will be equal to plus 1 by C by delta C by delta T. And for this product, since it is increased, plus 1 by D and delta D by delta T. Just remember that the coefficient becomes 1 by that number. Okay, and if it is the reactant, it gets decreased, so we have put the negative sign, and if it is forming the product, it is positive sign. Okay, in a similar way, the assignment for today is, what is the rate of reaction? Define it, write down the expression as well. Okay, and question number 2, so with the help of a graph, how concentration of reactant or products changes with time. And question number 3, express the average and instantaneous rate of reaction for the following reaction. Okay, so you need to express this in average, that is in the form of delta A by delta T, and instantaneous rate is minus dA by dt, like that. Okay, so express the average and instantaneous rate of the following reaction. Complete this assignment and send it in my mail.